So now we're going to talk about the last thing in this unit, and that is electron configuration. Your topic is electron configuration, and your goal is I can write the longhand and shorthand electron configuration of an element. So first off, we talked about electrons a lot. We know electrons control the chemical behavior of an atom. But we need to know that quantum mechanics describes the motion of subatomic particles and atoms as waves. The Heisenberg uncertainty principle states that it's impossible to know both the velocity and the position of a particle at the same time. You can know one, you can know the other, but it's impossible to know them at the exact same instance. So the Bohr model, which we talked about when we did the history of the atom, but that's basically saying that each orbit has a fixed energy. These fixed energies an electron can have are called energy levels. The higher an electron is on the energy ladder, the farther it is from the nucleus. And you need more energy to get to each step. For example, if you have a big old ladder, it takes way more energy to climb to the very top than it does just to get on the first step. Well, that's the same for electrons. It takes a lot more energy to get farther away from the nucleus than it is to get close to the nucleus. So to move from one energy level to another, it takes just the right amount of energy in order for it to be in that energy level. Electron configuration. So electron configuration is the distribution of electrons of an atom or molecules in atomic or molecular orbitals. And we'll talk about what that means, like what in the world that means, in just a second. So here we have what the electron configuration looks like. It's been moved. There we go. So it has 1s1. This one, or this slide, you'll see is actually in your digital notebook on this first page. So you need to type these boxes what these numbers mean. So the number in front, that is the row number. It's also the shell number. The possibilities, the numbers that could be in there would be 1 through 7 because there's 7 rows on the periodic table. The letter, that is the subshell possibility, and that's S, P, D, or F. And then the exponent, that's the group number, and that's the valence electrons. And then there's the possibilities listed. Now, I know you probably have no idea what I'm talking about right now, or you have no idea what's going on. Well, in this next clip, I will actually be showing you how this works on the periodic table, and it's basically just a big fancy pattern. So here, if you click this Google Doc, it'll open up and it'll be a blank periodic table. You will need to fill in that blank periodic table just like how I just showed you in this video, and then share it to randerson@roanschools.com. So today I'm going to show you guys how electron configuration works. So you notice here I have 4 different sections. I have the S, the P, the D, and the F, and we'll talk about why I have it split up that way in your digital notebook if you're a virtual learner. If you go to the next slide, you'll see where it says click here for a blank periodic table. Go ahead and click on that and open that because you'll need to fill this out just like how I'm filling it out right here on a piece of paper. I am color coding. If you want to color code, you need 6 different colors. So each row will tell you what number goes up front. You should have this already labeled in your digital notebook or at least seen it in the notes. The letter in the middle is the orbit, and the exponent is the number of electrons in that section. So I have my first color. Here we are in the first row, so this number is going to be a 1. It's in the S section, so it's going to be the S. And it's the first one, so it'll be 1s1. Now we read it like a book. we're still in this first row, so that'll be a 1. We're still in the S, so that'll be an S. But now we're on our second box, so that'll be 1s2. So now we're done with number 1. So now I have my second color. We're in our second row, so that's going to be 2s1, and this one will be 2s2. So come over here. We're still the 2, but now we're in the P section, so that's going to be 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. All right, now we're on to our third row. So this will be a 3. We're in the S section, and it's the first box, so that will be 3s1. This will be 3s2. We come over here, 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. Now you'll need your number 3 in just a second, and I want to explain why, so just kind of set that aside. Now I have number 4. 4s1, 4s2. So now we're in the D section. Now D's a little different. D is always one step behind whatever's going on with the S's. So since this is 4s2, then this is going to be 3d1. So it's always one step behind whatever's in the S's. So it's 3d1. This will be 3d2, 3d3, 3d4, 3d5, 3d6, 3d7, 3d8, 3d9, 3d10. Okay, so now we're done with 3. And we'll finish off. Since this is 4 S's, then these are back up to your 4P. So 4P1, 4P2, 4P3, 4P4, 4P5, 4P6. All right, we're on to number 5. So this will be 5S1, 5S2. Now remember, D is one step behind, so since this is 5, the D is going to be 4. So 4D1, 4D2. Now this is the 4 letter D and then 1, not 40 like the number. So 4D3, 4D4, 4D5, 4D6, 4D7, 4D8, 4D9, 4D10. And now we're back up to 5. So 5P1, 5P2, 5P3, 5P4, 5P5, 5P6. So now we need our 6th color. And here it'll be 6S1, 6S2. Now for Chem 1, this is where we stop. In Chem 2, we fill the rest of the periodic table. But for you all, this is all we need to know. All right, so how in the world do you write the electron configuration knowing this? So here we have this periodic table. Here we have a regular periodic table. So let's say we want to write the electron configuration for, let's do beryllium. So Be. Now this is the longhand. So you find where beryllium would be on here. So beryllium would be in this box. So we read this just like a book and we write it out until we get to the element we're looking for. Now you do not have to write every single box. You only have to put the one with the biggest number in each section. So for example, here we have 1s1 and 1s2. So you would just have to put 1s2. And then we have 2s2. That's all we have to write for that because 2s2 is where we're wanting to go with beryllium. So let's do another example. Let's do chlorine, so Cl. So chlorine is right here, so that means it would be right here. This is where we're wanting to go. So for chlorine, we read it. It goes 1s2, 2s2, 2p6, 3s2, 3p5. I stop at 3p5 because that's where chlorine is. That's where we're wanting to go. So that's how you do longhand electron configuration. Let's do one more example. Let's do iron, or Fe. So we're going to find the longhand configuration for Fe. So we find Fe on here. So Fe's right there. So that's 1, 2, 3, 4, 5, 6. So we know it's going to be 1, 2, 3, 4, 5. Right here. It's the same square of where it's at on the periodic table. So we start from the beginning. So 1s1, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. We stop at 3d6 because that's what we're wanting. We're wanting iron, or Fe, which is in that square. So that is where we would stop for iron. So this is the longhand. Now I want to show you a shorthand way for you to write electron configuration. So for the shorthand, first let's do calcium, Ca. First you find the element, so Ca is right there, which means Ca is right here on our periodic table. So that's where we want to go. All right, so when you write the shorthand, you have your periodic table. You go backwards until you get to the last noble gas that you pass. So in this case, we go backwards. So Ar is the last noble gas that we pass. So you put that in brackets. So here we have Ar. So Ar is right here. So we find that. Now all we have to do is write everything after that until we get to the element we're talking about. So here's Ar. Here's where we're needing to go. So we would just have to put 4s2. So that keeps us from having to write all this stuff in the beginning. So let's do one more. Let's do iron. So here is the longhand of iron. So let's see what the shorthand would look like. Iron is right here, which is this box right here. So first thing we do is we go backwards until we get to the last noble gas that it passed. Well, in this case, it's Ar. So we'll put Ar in brackets. And it needs to be brackets, not parentheses. All right, so Ar's right here. We're trying to get to here. So we'll write 4s2, 3d6. And that's it. We stop at 3d6 because that's what we're looking for. If you need more practice, or if you're still not sure where I'm getting these numbers at, please let me know. I know this is tricky, especially if you're not here in class. It could be very overwhelming. And please let me know before test day, like while you're actually having your questions. You can email me. You can schedule a Google Meet. You can message me on Canvas. Whatever you need to do, I will help you with this. I'll help you get through it. And I hope you have a great day. Now that you know how to write the longhand electron configuration and the shorthand electron configuration, you'll need to answer these 2 or 4 questions. These 2 are longhand, these 2 are shorthand. How you get subscripts is if you go to Format, Text, and then that'll be a superscript. So you click superscript. So to show you again, Format, Text, superscript. And that's how you draw that. Now to make that no longer a superscript, you will have to go through and click it again, and now it is back to the regular format. If you have any questions on this, please let me know. I will be happy to help you. And I hope you have a wonderful day.